In this video, we're looking at sections 11.4 and 11.5 together. And they're actually very nicely combined sections because we're looking at circumference of a circle and area of a circle. So in 11.4, we look at first circumference of a circle. We actually have two formulas to choose from for circumference: pi times diameter, or 2 pi times the radius. These both give us the same thing, but they're different because we know that the diameter is in fact 2 times the radius, so we can rearrange it and write it in either case. Typically, we'll see it written as 2 pi times the radius, and we actually have them written right there. Now, circumference represents the distance around the circle. This is different than what we looked at back in chapter 10, where we had a degrees representation for around the circle being 360 degrees. Now we're looking for an actual distance. So if it was an object, a circular object we looked at, we could see how far it would be around, maybe in inches, centimeters, feet, miles, and so on and so on. So it's that distance around is what we're looking at. We're going to use degrees a little bit later on to help us find part of the circle, but circumference is the distance around. Now what we also have here is the introduction with pi. Now, pi is not technically 3.14. That's going to be our approximation for pi. What pi actually represents is the ratio of the circumference over the diameter. And this is a relationship that exists within any circle. Now we say it's about 3.14. That tells us that the circumference is about 3.14 times bigger than the diameter. That relationship helps us get to how to find circumference, but that is actually where we get pi from. So if someone asks you what pi is, you're going to say it's circumference over diameter as opposed to 3.14. Now, back to the actual circumference problems. If we look at the examples we have below, we're looking for the circumference of a circle with the radius of 9 centimeters. We're going to do c equals 2 pi r. We know the radius is 9. We plug that in. 2 pi times 9 gives us 18 pi centimeters. Now, that is what we call in terms of pi. It's the most exact form because if we used pi in a calculator or 3.14, it would be an approximation. So if it says in terms of pi, you can leave it as that. If we actually take our calculator and multiply by pi, we get that as approximately 56.5 centimeters, and that is an approximation. Even using the pi button on our calculator is still an approximation because it won't go on infinitely. It's eventually going to round. So 18 pi or 56.5 centimeters. For B, it's asking us to find the radius of the circle with the circumference 26 meters. So we're going to do c equals 2 pi r. Circumference is 26 this time, so 26 equals 2 pi r. I can divide both sides by 2 and get 13 pi times r. And since pi is just a number, we're going to divide that by both sides and get 13 over pi equals r. Again, that is in terms of pi. If I wanted to divide 13 by pi in my calculator, I would get that it is also approximately 4.1 meters. And that's meters for both of these. So, given a radius, given a diameter, and we'll look at a couple of those a little bit later as well, we could find the circumference. Now we're going to take a step forward and do a little bit more. We're going to look at arc length. Now, we actually have a proportion we can start with, and this kind of uses stuff we've looked at last chapter and what we're introducing now. So if I look at the arc length of AB, that is the distance it is from A to B on this circle. How far it would be in units, inches, meters, centimeters. Not so much degrees, but an actual distance we could represent. I'm going to compare that to the circumference. So this distance compared to the entire circle is equal to the measure of arc AB, which is back what we've done before, which is the same as angle P, compared to 360 degrees. Now, This we're not going to use, but it's key to get us to how we're going to find our actual arc length. We're going to say that the arc length of AB, or that distance from AB, is equal to the measure of arc AB over 360 times 2 pi r. Now, I can make that a little more general. So if I look at the length of the arc, that's going to be the measure of AB, but typically it's going to be in degrees, and we want to think of that as the angle. So the measure of the angle over 360 times 2 pi r, which is the circumference. So we want an actual fraction times the circumference. So if we look at our examples, and we'll start to see how this relationship actually exists. I have my circle here, so the length is equal to the measure of the angle over 360 times the circumference, which is 2 pi r. I plug it in. The angle is 60 degrees divided by 360 times 2 pi times 8. Now, it's really two parts we're doing here. 60 over 360 is 1/6. So with that 60 degrees, I am taking 1/6 of the circumference. I don't want the entire distance around. I want 1/6 of it. And that's what I have there because it's 60 over 360. That's times 16 pi. What 16 pi represents is the distance all the way around the circle. We want this fraction of the whole thing. If it asked for the total circumference, it would be 16 pi. But we want that 60 degrees of 360, or that 1/6 of it. I can combine these to simplify. It becomes 16 pi over 6, which is eventually 8 pi over 3. Again, that is in terms of pi. We could leave it as that. If we wanted the approximation, we would do 8 times pi divided by 3, which comes about to be approximately 8.4 centimeters. Okay, let's look at the next one. So again, we look at the measure of the angle over 360 times 2 pi r. Our angle is 60 degrees over 360, and working ahead, that's again going to be 1/6. I want 1/6 of the entire distance around. My radius is 11, so I plug that in and I get 22 pi. The entire distance around the circle is 22 pi. I want 1/6 of that. So 22 pi over 6 is my arc length. I simplify that and get 11 pi over 3. That works for being in terms of pi. 11 times pi divided by 3 is approximately 11.5 centimeters. That tells us the distance from E to F is 11.5 centimeters in this case. Now, if we go to our next one, I have 11 centimeters. As my radius, I now have 120 degrees. Comparing it to the previous one, the radius is the same, but now the angle is twice as big. So even before we do this problem, the fact that this 120 degrees is twice as big as 60, what we're ultimately going to find out is, does that mean that this arc from H to G is twice as big as E to F? And if it is, it's going to be 23. So let's just write 23 over here and see if we do happen to get to that answer. So we start again. The measure of our angle divided by 360 times 2 pi r. I get 120 over 360 times 2 pi times 11. 120 over 360 is 1/3, so we're looking at 1/3 of the circle, or 1/3 times 22 pi. Gives me 22 pi over 3, which that's in terms of pi. I can now simplify that, and that's 22 times pi divided by 3, which comes out to be about 23.0 centimeters. It's actually 23.038. Let's do 23.0. Now, if we look, it did in fact turn out to be twice that. which makes some sense because now we're only looking at 1/3 of the circle, where before we were looking at 1/6, which is actually half of that part. So it'd be like almost from here to here. So it should be twice as much. I could even go far to figure out what the entire distance is around, because that is still 22 pi. So let's start playing with some different types of problems as we start looking at circumference and arc length. Now, in our next one, we're looking for the circumference of the red circle. That is this circle, and even though you can't see in the copy, the middle circle on that second example. In the circle on the left, I have a square. I have a diagonal within that square, which is 4, but that diagonal is also the diameter of the circle, because it goes from one point on the circle to the other point through the center. That means our radius of the circle is 2. So, to find our circumference, I can either use 2 pi r or pi times diameter. If it's 2 pi r, I get 2 pi times 2, which is 4 pi. If it's pi times diameter, I get diameter, or pi times 4, which is 4 pi. Either case, it is the same answer. The next one, I have the total length of all three of those segments is 27. That means each one is going to be 9. Now, if each one of those is 9, that is a diameter, which means my radius for each of those is in fact 4.5. So when I want to find circumference, I could do 2 pi times the radius, or 2 pi times 4.5, which is 9 pi. Or since I do know the diameter, pi times the diameter, or pi times 9, which is 9 pi. And again, we got the matching answers. You don't have to do both, just do one of them to get to the correct answer. Should be noted though, be careful though when you take half. When you take half on this one, the 9, half of 9 is not 3, it should be 4.5. We don't want to suddenly take the square root when we shouldn't. Okay, moving on, now we're looking at arc length, and again, arc length, we're going to look at the measure of the angle over 360 times 2 pi r. I could use pi times diameter if they did give me diameter, which they happen to do here, but for the sake of consistency, I like to keep it at 2 pi r. So, for this one, we get that our angle is 30 over 360 times 2 pi times 4, because if 8 is our diameter, 4 is our radius, I get 1 over 12 times 8 pi. 30 over 360 reduces to 1/12. So we're actually looking at 1/12 of the circle here. The distance around the circle is 8 pi, so 1/12 of 8 pi will be this distance. That becomes 8 pi over 12, which we can reduce to be 2 pi over 3, and that is inches. And we can simplify that, or approximate that one. 2 times pi divided by 3 is approximately 2.1 inches. For our next one, we have 150 degrees is our angle. 150 over 360 times 2 pi times radius. Radius is half of that, 20, so it is 10. 150 over 360 reduces to be 5 over 18 times 20 pi. Here this is 5/18 from these two. Not 5/18, we need to fix that one. It should be 5/12 times 20 pi. 5 times 20 gives us 100 pi over 12, which I can divide both of those by 4 and get 25 pi over 3, which is our answer in terms of pi, and we can simplify that. Not simplify, try again. We can approximate that. And we get it's about 26.2 centimeters. So, as you go forward, working on those, keep in mind circumference is 2 pi times radius or pi times diameter. Be sure to specify and use the correct one whether you're given radius or diameter. I like to use 2 pi r just for consistency and just always make sure I'm using radius. And when you need to find arc length, it's the measure of the angle or the measure of the arc over 360. That gives you a fraction of the circumference. So you find that circumference, you find the fraction, you multiply, get it in terms of pi, and then you can write it as the decimal as well. Now, moving on to 11.5, and this is where 11.5 starts. 11.5 now goes to the area of a circle. Before we looked at circumference, which was the distance around, now with area we're looking at the space that it takes up. So this is pi r squared. Now, we're only going to use radius here. If we're given diameter, we're going to take half of it. So we have the radius. And sometimes students easily mix up the two. And one way to think of it, in area I have units squared. Centimeters squared, inches squared, feet squared. So the formula that I'm going to use for area of a circle is going to have the radius squared. The other one was 2 pi r for circumference. Here it's radius squared. I square it because my units are going to be squared. So if that's something that helps you, use that, but we need to make sure we specify for area. It's pi r squared. So for our first one, we have the radius is 3, so area equals pi r squared. We plug in the 3 for r, and we get 9 pi inches squared. That is in terms of pi. If we then multiply 9 times pi, we get that it is about 28.3, and that would be inches squared. Second one, we're given that diameter is 20 feet. We don't want diameter, we want radius. So that is actually 10 feet. Area equals pi r squared, so we'd say that the area equals pi times 10 squared, or 100 pi. And if we plugged that in to get an approximation, we'd get it's about 314.2, that is feet squared. So those are your straightforward ones. Let's look at one a little bit more, looking at areas of shaded regions. We've talked about different shapes so far this chapter. Now we start to combine them a little bit. If I look at this shape down here, I have these two circles. They're kind of overlapping my shade, or covering up my shaded region. If I find a large area to start with and subtract some of it that's not included, I can find the area of the shaded region. For example, I have a square here. This square is 6 by 6. If I subtract out the area of this half circle and this half circle, I will have what's left over. Now, if I had a half circle and a half circle, together they give me the full circle, and by subtracting that I would actually get the shaded region that I'm looking for, which is that portion. It's the portion that those circle parts are not covering up. So I can find the area of the square, I can find the area of the circle together, which does have a diameter of 6, radius of 3, which would eventually get me to this area. So area of this square is side length squared, or 6 squared, which is 36 meters squared. Area of this circle is, I need to use radius, it's going to be pi r squared. So that's pi times 3 squared, or 9 pi meters squared. So that means I'm going to do 36 minus 9 pi meters squared, and that's in terms of pi. Then to approximate that, I'm going to do 9 times pi, which is about 28.3. Subtract that from 36, and I get about 7.7 meters squared for the area of the shaded region. That is the area that's there that is not covered up by the circle. Now, as we move on a little bit, we now have the portion of the circle, like we had for arc length, that's going to apply to area. We start off with the same type of proportion as earlier. I have the area of sector APB. That is this portion of the circle. It's like the slice of pizza that comes from the circle. That's APB. that compared to the area of the circle, or the whole thing, so this piece compared to the whole thing, is equal to the measure of this arc in degrees, or its angle, to 360. So those are equal because it's a portion of the whole thing. But again, like earlier, I move over this pi r squared by multiplication, and I get the formula we're going to use. Now, this formula tells us the area of that sector is the measure of the arc over 360 times pi r squared. Or the area of the sector is equal to the measure of the angle, or in degrees, over 360 times the area, which is, of course, pi r squared. So, we look at our first example. We really have two sectors here. I have this darker shaded one and this lighter shaded one. I'm just going to number them here. I'm going to have 1 and 2. I'm going to find the area of each of those. So, the area for our first one. Now, it's going to be the measure of the angle, 45 over 360, times pi times 5 squared. To go over the parts again, this is the fraction I want. 45 over 360 is 1/8. I want 1/8 of that whole circle. It's like a slice of pizza. I want that 1/8 of it. If it was 8 slices, that would be 1 slice. But I want what of the total area? This is pi times 5 squared, or 25 pi. Total area is 25 pi. I want 1/8 of it. So that is 25 pi over 8, which is in inches squared. I can then approximate that, and that gives me about 9.8 inches squared. Okay, now we look at the area of the other sector, sector number 2. If I look at what the degrees would be for that arc, it's not really an angle, it's more of an arc, I would take 360, subtract 45, and get 315 over 360 times pi times 5 squared, because the area is the same. Now we can actually kind of skip that step, because in the first one we knew it was 1/8. If this is 1/8, well, the rest of it would be 7/8. So we want 7/8 of the total area, 25 pi, to give us the area of that sector. 25 pi is the entire area. We want 7/8 of it, or this little piece not counted. So that, simplifying it, becomes 175 pi over 8 inches squared, which is approximately 68.8 inches squared. So that's the area of the larger sector, which we can see is by far a lot bigger. Now, real quick, if we looked at the area of the whole circle, we found that it was 25 pi. We found it here, we found it here. We can also see it's just pi r squared. That is approximately 75 or 78.5. Now, if I combine these two, looks like we rounded on here. Let's check. That's right. We want to make this 68.7 just to help our point be a little clearer here. If I combine these two, 9.8 and 68.7, I find that they do in fact add up to 78.5, which they should, because that's the area of the whole thing. If I knew the area of the whole thing and I subtracted off one of the sectors, that would be the sector that was in fact left over. So we could also use that to help us. Typically, though, most of the time we'll be finding the area of the individual sectors. So a couple more to work through. In this one, I see that both of my sectors are equal because they're each 180 degrees for the arc or the angle. So for each of them, it's going to be 180 over 360 times, now it's going to be radius squared. Our radius isn't 22, it's 11. So I'm looking for 1/2 of the area, that is 121 pi. Area of the whole circle is 121 pi. We want half of it. Doesn't matter which sector because they're actually both equal. I want half of the circle. That comes out to be 121 pi over 2, which is approximately 190.1 centimeters squared. And that's for each. That's the area of 1 and the area of 2. For the one on the top right, if we looked at 1 and 2, our area of 1 is going to be 100 over 360 times pi times 7 squared. 100 over 360, I can cross out the zeros, and I get 10 over 36, which is actually 5 over 18, times 49 pi. So we want 5/18 of 49 pi. This becomes 245 pi over 18 feet squared, which we can make as a decimal to be about 42.8 feet squared. Now, the area of sector 2 is going to actually be 260, because that's 100 from 360, it's what's left, but we kind of already know it's going to be 13/18 once we reduce, because if that's 5/18, then I have another 13/18 to represent the whole thing of 49 pi. So 13 times 49 gives us 637 pi over 18 feet squared, which we're going to simplify to be about 111.2 feet squared. Okay, last one. Let's number them. I have sector 1 and sector 2. Look at the area of 1 first. For the area of 1, my angle, or my degrees that I'm going to use, I don't quite know yet, but I know 240 is this arc, so that one's going to be 240 over 360 times pi times 2 squared. Now 240 over 360 is actually 2/3. So that is actually 2/3 of the circle, which means this one is 1/3, or 120 degrees here. Now it's also going to be 4 pi, like the one we have there. That makes it 4 pi over 3 yards squared for sector 1, which is about 4.2. And then I get 2/3 times 4 pi, which is 8 pi over 3 yards squared, which is approximately about 8.4 yards squared. Now we said area 2 was twice as big as area 1, that sector, and it turns out it is 8.4 compared to 4.2. We could see and add them together, and we could find the total there. So the total for that circle, we would have to guess, would be about 12.6 from what we get from 4.2 and 8.4 added together.